Hello and welcome to another Drupal Easy screencast. In this screencast, we're going to be looking at merging and rebasing. And it's basically just like a visual look at what happens when we do a git rebase and then a git merge. In both these cases, we're going to be doing this where there are no code conflicts. So this is kind of like an entry level git lesson on what is actually happening when you do a git rebase. So as a setup, you can see we've got a little bit of a git tree here where all of these circles represent commits in your project. So time moves from left to right in this project. And you can see around commit 333333, someone created a new branch called feature run 1 and made a couple of commits there. And meanwhile, the master branch is at 777777, and we are currently, the working directory is currently looking at the master branch, and that is what the head signifies. Finally, when we are on the, whichever branch we happen to be on is, we call those commits ours. And I'm putting those in quotes because that'll, sometimes if you have to check out a file, you refer to them as ours or theirs. Ours are generally wherever you are in head, and theirs are the other branches commits that are being brought onto the current branch. All right, so let's see what a rebase looks like. When a rebase takes place, Git actually, well, I should say, let's kick off the rebase by saying we're going to do a git rebase feature 1 onto the master branch. So what happens when you issue a rebase command is Git will actually rewind the playhead back to the commit where the two branches diverge. So we're on master branch, so we have to rewind to where the feature 1 branch diverged. So we go back to the 333 commit. At that point, Git temporarily takes off the 666 and 777 commits, and then it plays the playhead forward along the feature 1 branch until it gets to the tip of the branch, until it gets to where the feature 1 branch name is. And that here is 555. At that point, once it reaches the end of that, then Git reapplies the commits it previously took off. And at this point, those are called theirs because ours is following head, so ours is pointing at 555. So now we're going to add theirs, which are 666 and 777. And there's no conflict, so those go on pretty easily. And then the master, and then the head, the git playhead rolls on forward to 777. So at the end of the day, we have all four of our commits, 444, 555, 666, and 777, applied to the code base, no conflicts, and we are up to date. And as you can see, if we take away, if we were to take away the labels and straighten everything out, we're left with a nice straight line history. Now, let's take a look at if we start in the exact same place, but we do a merge instead. So a merge is a bit different. So when we're on the master branch and we issue a merge command, we don't, Git doesn't go back in time. Git is going to look at the two divergent branches, and it's going to try to create a new commit that rectifies the changes in both branches. So in this case, it calls that commit, just gives it the proper hash, which is again a calculated value, but of 888,888. So this is not a commit that anybody created manually by modifying code. This is an artificial commit, or some people call it a merge commit, that Git creates in order to rectify two divergent branches. And really, that's it. Like I said, that's all there is to it. The downside of doing a merge, at least in my opinion, is that you're left with this merge bubble. So you can see you kind of have a closed loop of commits. And that's not nearly as nice as a nice straight line history, because what happens if you want to go back in time to this commit right here? So if you go back in time to this commit, not only are you losing 555 and 888, but you're also losing 777 and 666, which you may or may not want to do. So when you're traversing Git history, it's always easier to have to deal with a straight line history. And there you go. That is the difference between Git merging and rebasing.